Alright, so last week we were talking about the bowl of soup. I don't think we even got to the bowl of soup in this class, or if we did, we went really fast. Alright, so this is our scenario. Bowl of soup is, so this is still 4.2 material, and then through our 4.2 lens, we don't solve that problem today using something called a logarithm. But before we know about logs, a bowl of soup is removed from a stove at 200 degrees, placed at a room that maintains a temperature of 72 degrees. This is our equation. So if it comes out of off the stove at 200 degrees and it's approaching room temperature, is the temperature going up or down? Down. You answered, then you thought about it, and then you answered confidently. I like it. Okay, so it's going to be exponential. It's going to be kind of like the one up above. It's going to start, and it's going to go down, and it's eventually going to become really, really close to the room temperature of 72 degrees. So the equation, T equals 72 plus 128 e to the negative 0.0428 T, where capital T is the temp, and lowercase t is the time, probably in minutes here. Okay, so a couple of questions after 30 minutes. So t is minutes. Go ahead and do that. Find the temperature of the soup after 30 minutes.
Wait, what's E?
Oh, good question. So E is an irrational number, kind of like pi. It's found on our calculator, so go ahead and throw your calculator. No, stop throwing, I was kidding. So there's a button right there, that's the E. Or there's an e to the power right here. So it's so important it's on there twice. So if I just want to know what E was, it would be, type in E, and it's 2.718, yada, yada, yada. So it's just a number. We'll learn more about E. In fact, E is really, really important in future math classes. It's used almost every day in calc class. So it's not something that's kind of like I and kind of goes away for a long time. E is something that's going to stick with us a lot. So find the temperature after 30 minutes.
How did they derive?
It's named after a guy named Leonard Euler, so he's pretty smart. One of the most famous mathematicians of all time.
Notice how pi is the ratio of like the circle to the radius.
Right.
Like what's E?
E. So E is the base of an exponential function. So if something is exponential, it's going to have a base of E. It could be written with a base of E anyways.
It's the E with the variable, because in
Alright,
it's like X.
so hopefully by now you figured out that just plug 30 in for time. So it's going to be 72 plus 128 e to the negative 0.0428 times 30. One mistake I would anticipate is you have to put this, either multiply these or put it in parentheses. Otherwise you're just taking e to that, and then whatever result you're going to multiply by 30. You have to take it to the entire exponent. Alright, so 107.45. What did we just figure out?
The temperature after 30 minutes.
Very good. So is that if we started at 200, it's approaching 72 degrees, is it reasonable that it would be 107 degrees after 30 minutes? Yep. Well, at least it's not 300 degrees, right? Or 30 degrees wouldn't make sense either. It's not going to get colder than the room. Okay. So, second question, when will the temperature reach 100 degrees? Well, we just said after 30 minutes, it's 107 degrees. So a reasonable answer would be what? What would a reasonable guess be? We're still throwing our calculators.
I know, I got 25 minutes.
25 minutes. Do we agree?
35 minutes.
Or 35, yeah.
So it's got to be more than 30, right? All right. So we
That
don't.
was actually really, really close.
So what we're going to do is make our temperature 100 and plug that in for capital T, and we need to figure out what lowercase t is. So the first thing we could do is subtract 72.
Your app has been blocked.
It's YouTube, eh?
All right, now what? Good, divide by 128. Whatever, 14 over 64 is 7 over 32. Now how do I undo e to the power? What's the inverse operation of that?
Take the root.
Square root?
No,
Well,
the negative zero.
Cube root, the e root. Okay, so that's our roadblock. That's what we need to figure out in 4.3. We don't know how to undo e to the power. We wouldn't know how to undo like 3 to the power, like 3 to the x. What's the opposite of that? You can't say cube root because the opposite of x cubed is cube root, but the inverse of 3 to the x, we don't know. So if the base is a number, we don't have the ability to undo it right now. So we use our calculator. Let's go back to right here. Let's graph y equals 100. And we're going to graph y equals 72 plus 128 e to the negative 0.0428 t. If we graph both of those, we can find where they intersect, and we have our solution. Okay, so try to calculate the intersection of those two. Go ahead and do that. Hit graph. To zoom out or adjust your window. I'll give you a minute.
I still need to type it in.
All right, so it's kind of a struggle to find it on the calculator screen. So there's my regular zoom standard. I could zoom out.
Just like do the zoom fit.
Zoom fit, does it work? All right, so zoom out. Nothing happening. Hit enter again. Zoom out. Nothing happening. Hit zoom out. Oh boy. So zooming out. Oh, we got something. That's like my 5th or 6th zoom out. That actually looks pretty good.
Why is your...
Okay, so that's actually kind of lucky that I was able to zoom out like 5 times and it looks pretty good. This is the temperature coming down into the room. You can see that this must be the horizontal asymptote, y equals 72, because that's the room temperature. There's a horizontal line right there. And there y equals 100. That's the blue line going across. Yep.
My line goes up.
It goes up?
Yeah.
So you must have entered it in incorrectly. Okay, so if I was doing this problem, I would not zoom out 5 or 6 times. Okay, I would look at the domain and range of the problem. We know that 30 minutes, we're guessing about 35 minutes and we'll have our answer. So I'm going to go to window. In my X max, we think it's about 35. I'll put like 60 just to make sure. Y max, We know they want to intersect at y equals 100, so maybe I'll do a y max of 150, and that might be enough to just look at. So the y max is 150. We know it started at 200. It's going down. We want to know when it's at 100. If I hit graph, without zooming out 5 times, just by changing the window, it's a lot easier to manipulate. Okay, so we want to know when they intersect each other. How do we know how to find intersect? Is trace the best way of doing it?
No.
No.
You got it, like,
Not table.
calculate, yeah.
Calculate.
Intersect.
Intersect.
Intersect, sorry.
Okay, it asks us first curve. We only have 2 curves. I'm just going to hit enter. Second curve, hit enter. Put it on top of where you think they intersect. Hit enter. And what do we get? 35.5. About 35.5 minutes. All right. So if you don't know how to solve equations, you can always use your calculator. There's actually equations in math that you can analytically solve. So you have to just here.
Wait, then how
Your
does-
first y equal to 100, second equal to the other side of the equation, and you can just find the point of intersection. Okay? Sometimes that's what you have to do. Like if you had a cubic equal to an exponential, this is what you'd have to do. All right, so that is 4.2. We needed our calculators in order to solve that. If we wanted to analytically figure this out, right here, we'll pick up right where we left off. We got down to 7 over 32 equals e to the negative 0.028t. What we can do is a logarithm. If you have an exponential, like our 3 to the x, the inverse of 3 to the x is log base 3. It's a logarithm. They undo each other. If I had 5 to the x, the inverse of 5 to the x is log base 5. Here we have e to the x. The inverse of e to the x has a special logarithm. It's log base e, but it's special enough where log base e actually is just the natural log.
Yeah.
It's implied that log base e is just natural log. So e to the x and natural log are inverses of each other. So we can take the natural log of each side right here. On the left side, we have natural log of 7 over 32. On the right side, each other is negative 0.0428t. It got rid of e.
That's how you calculate it.
Okay, now we're one step away. We can divide by negative 0.0428. So t is all of that stuff. So I'll figure out what it is.
Hey, no calculators.
Well, we need a calculator for this. But we would not need a graphing calculator. So natural log, same button as the e to the power. It's right here. It looks like a 1n. It's natural log and ln right here. So natural log of 7 over 32 equals, and then divide by negative 0.0428. And that answer looks pretty familiar to us.
It does.
Okay, we did not need to graph it. We could just undo it with a natural log.
Shall we write the cursive natural log?
It's up to you. Okay, so I told you that they're inverses. Logs and exponentials are inverses. This is what y equals 10 to the x looks like. So if you're following along at home, you can turn the page. Y equals 10 to the x, and this is y equals log x. There's 2 logs that you do not have to write the base for. Natural log, we know that it's base e, and the other one is log. It's called the common log. If there's no number there, anybody know what the base is?
Like 12.
It's 10. Okay? If there's no number there, that means the base is 10. Kind of like if we have a square root, we get lazy, and there's so many square roots compared to other ones, we don't write a 2 every single time. We just say, we'll call that square root. Here, we don't have to write 10. We can just leave it blank knowing that it's log base 10. There's 10 to the x. That's an exponential. Remember, it has a horizontal asymptote at y equals 0. Here's log. This is y equals log of x. It actually has a vertical asymptote at x equals 0. This one is y equals 0. This one is x equals 0. This one intersects at 0, 1. It makes sense if it's an inverse, it intersects at 1, 0. These are inverses of each other. Okay, as I talked about, here's several examples of inverses. Natural log and e, log base 3 and 3 to the power. If it's just log of 10, that means it's 10 to the power is the inverse. Log of muffin and muffin to the x are inverses. It kind of looks, I'm thinking chef hat. We'll go chef hat. I probably attempted cauliflower there, but it's got a really thick base, so looks more chef
You're
hatty.
eating some weird cauliflower.
I know. It's good for you though.
Broccoli's better than cauliflower.
I'll eat my
I will die until broccoli's better than cauliflower.
Cauliflower is better than broccoli.
Cauliflower's way better. I've never
No, broccoli's better than cauliflower.
I've never enjoyed
Yeah,
that.
cauliflower sucks. Broccoli's good.
Broccoli's like good.
Yeah. They don't.
I agree.
I'm pretty sure.
There are ways. I don't.
Okay, so there's two different types of equation. We've got exponential form, we've got logarithmic form. They're the same equation. This is an equation. 4 is equal to the log of 16 base 2. Okay, log of 16 base 2 is equal to 4. We can write it in log form. Or actually, it's in log form. We can write it in exponential form. So we need to undo the log base 2. So log base 2, its inverse is 2 to the power. So we're going to do 2 to the power of each side, and that will undo the log base 2, and we're left with 16 equals 2 to the 4th. Is 2 to the 4th equal to 16?
Yes.
2 times 2 times 2 times 2. Yes, it is 16. Okay, if you're given an exponential and you wanted to write it in log, we do the opposite of what we're doing. It's 2 to the power, so we would do log base 2 of each side. That undoes the 2 to the power. I'm left with 4 equals the log of 16 base 2. Okay, we're right back where we started. You have to be able to undo whatever form it is given. Okay, that'll allow us to solve equations, rewrite expressions, rewrite equations, things like that. Put my glasses on so I can see. Another one, we have 2 equals the log of 3x base 5. We have to do the opposite or the inverse, so we're going to do 5 to the power. That undoes log, so I'll have 5 squared equals 3x. We could actually solve this because 25 equals 3x, and then you could divide by 3, so x equals 25 over 3. So we just solved a logarithmic equation. The first thing you should do is write it in exponential form, and you can solve it. Alright, so if I have, I think that's enough. Why don't I give you one to try it? Let's say I have 8 equals alright, see if you can, well that's a big number. Oh, that's alright, you got calculators. See if you can solve that equation for x. All right, so we have to undo log base 2. That is 2 to the power is the inverse. So we have 2 to the 8 equals 4x. 2 to the 8, what's that number?
256.
256 equals 4x. Divide by 4. So x equals 64, right? Everybody got 64?
Yes.
All right. I want you to rewrite this one in log form.
Do we have to? How much is
All right, all we're doing is rewriting here. We have a base of a, so we have to do log base a of each side. That will undo the a to the power. So b equals the log of c base a. How many add that?
beast?
Good.
Oh, yeah.
All right, a few more things. What about the log of 1 base 6? What is that equal to? We're going to evaluate. So we're evaluating, we're figuring this out without like a calculator. What is the log of 1 base 6? If we don't know, which we probably don't, what you need to do is set it equal to x, and now write it in exponential form and see if that helps you. So this is a question you'd see on a test or a quiz, and you'd have to show your work and do it without a calculator. Okay, as I said, exponential form, we're going to have to do 6 to the power of each side. That will undo log base 6. So I have 1 equals 6 to the x. So 6 to what power is 1?
0.
0.
Oh.
Very good. So don't write x equals 0. Write just 0, because there was no x in the original problem. I just asked you to do this. The log of 1 base 6 is 0.
If we do x equals 0, we get points off.
You will get 100 negative points if you do that.
Uh-oh.
I'm kidding. How about log of 1 base 3?
You.
Try that one.
Wait a minute. It probably is. Isn't it 0?
You don't set it equal?
Set it equal to x.
That's big.
All right, so if we set it equal to x, we do 3 to the power. We have 1 equals 3 to the x. 3 to what power is 1? 0. So what about the natural log of 1? What's that going to be? Zero. What about the log base hert of 1? What's that equal to? So any log of 1, it'll always be 0. Okay? The log of 1 is always going to be 0. What about, let's say, the log of 5 base 5? See if you can figure that one out. Alright, so if we set it equal to x, we could do 5 to the power. So I have 5 equals 5 to the x. 5 to what power is going to be 5? 1. What about the log of 10 base 10? So if these two numbers are the same, you're always going to get 1. Alright, let's try one that's not kind of a special case. What about the log of 16 base 2? It's at home. Alright, so log of 5 base 5 is going to be 1. The log of 10 base 10 is 1. So if these two numbers are the same, then you're always going to get 1. try this one that's not a special case. All right, so log of 16 base 2, you can set it equal to x. We do 2 to the power, so that'll undo that. 16 equals 2 to the x. 2 to what power is 16? 4. So we can figure out that the log of 16 base 2 is just 4. That's all I have time for today. Thank you very much.